This is Natural Selection Lesson 2.2, Activity 2. So let's take a look at the Chapter 2 question. So now that we know where individuals and populations get their traits, we can continue to think about how the trait for poison level became more common in the newt population. So again, chapter 2 question is, how did the trait for increased poison level become more common in the newt population? We know traits, individuals get their traits from their parents. So it's going to help us look at this question. We're going to look at a couple claims we had at the end of chapter 1. Agreed that the newt population became more poisonous because the snakes in the environment caused poison to be an adaptive trait. But now the park visitors are offering additions to this claim. So some park visitors have offered two competing ideas. Some park visitors have suggested that poison level 10 is most common because newts with this trait live longer than other newts. Others think that poison level 10 is most common because the newts with this trait reproduce more than other newts. Each of these ideas builds on the claim we decided to support at the end of chapter 1, but now we need to figure out which one is best supported by evidence. So to be able to support one of these claims, we need to understand why traits become more common in a population. In previous activities, we looked at how offspring get genes from their parents when organisms reproduce. Genes are instructions for making protein molecules that describe an individual's traits. How is it possible then that some traits can become more common over many generations while others become less common over many generations? If offspring are inheriting their traits from their parents, shouldn't each generation match the generation before it? So that is our investigation question, is how do some traits become more common over many generations while others become less common? We saw this happen in lesson 2.1 when I showed you the activity with the cubes, where the blue cubes ended up being mainly the only cubes in the end. So the traits, the blue trait, became more common over the generations in that activity. So that question is, well, why does that happen? All right. So we're going to do a sim activity, or I should say you're going to do a sim activity, and then we're going to talk about it together after. So in the sim, you're going to be going to reproduction claims. So I'll let that load for a little bit. You're going to be gathering evidence about whether australopes with adaptive traits have more offspring than australopes with non-adaptive traits. So the goal, again, is to gather evidence to support or refute the claim that australopes with adaptive traits have more offspring than australopes with non-adaptive traits. In this environment, in the sim, the environment color is going to be yellow 7, and there's going to be carnithons present in the environment. So based on everything we've done before, we know that a yellow 7 environment with the presence of predators, that yellow 7 is the most adaptive color trait. So it's important to note that our sim mimics the natural world, which is very complex. Like the natural world, random events can occur in the sim world that could make it difficult to draw conclusions if we don't collect enough data. For example, some australopes might randomly have more opportunities to reproduce than others. So by collecting enough data, we'll be able to determine if the data shows a pattern that is not due to random events. So we're going to each collect data and then use all of it in a class data set, and I'm going to make this work for us in our scenario. Okay, natural selection and reproduction claims. Okay, um, so in lesson 2.1, we use this mode. I'm going to zoom in and I'm going to locate an australope with color traits from the data table. So if I go here, the data table says blue 1, blue 4, yellow 7, yellow 10. So I need to find blue 1, blue 4. So there's blue 4. Okay. So I'm going to select that australope and then I'm going to press run. All right, I'm going to follow the individual until it dies. And while I follow it, I'm going to see how many times it reproduces. And you can tell this thing got eaten right away, and so it did not reproduce. So what I would do is I would put a 0 in this category. And then I would reset the sim, and then I'd find, oops, I did that wrong because that was a 4, blue 4, so a 0 there. So then I'd go back to the sim, I would press reset, and then I'd find one with one of the other colors, so blue 1, yellow 7, or yellow 10, and do the same thing and press play and count how many times so here's a blue one, so let's look and see if it reproduces and see how many times it reproduces. So reproduces, and then I keep running it, it's reproducing. I can't tell if that was once or twice, I don't remember. So definitely at least twice, and then I think that's 3 times, and oh, 4 times, same ones. Oh, 5 times. So you never know how many you're gonna get, and I just run it until it passes away, and it's about to. So I think that's 5 or 6 times. We'll just say 5 times. So then you put a 5 in there. That's what you do for this whole thing. So that's how you do this activity. Once you're done with the activity, you're going to pause the video, go to lesson 2.2 activity 2, and once you're done with the activity, then you'll come back and play the video. Actually, I'm going to make this in 2 parts, so scratch that. Go to lesson 2.2, complete the sim activity on page 2, and once you're done with that, you will come back and watch the second video.